As you may have already guessed, we will be talking today about offline-first applications, about the ones that are able to function normally when both reading and writing data, even under the event of broken network. And we will also talk about the innovative methodology called Reflex, which will allow you to create highly interactive, fault-resistant, and offline capable and easy to make applications. But that's not the only thing that we will be talking about today. We will also touch the basis on which offline-first applications stand. We will also discuss distributed systems and client-server architecture in general. So I understand that this was a pretty rough morning, so be ready to jump from one topic to another, and so let's start. So to understand the nature of offline-first applications, we need to understand the historical background of client-server architecture in general. And I have found this image on the internet, and it has nothing to do with me, but for me it says a lot about the evolution of software architecture. So look at this bellissima pasta that we had like in 1990s, which was like copy and paste architecture that we had at those times. Then we had this lasagna-oriented architecture, which had a lot of different names like layered monolith, service-oriented architecture, entire architecture. So now we have this ravioli-oriented architecture, which is kind of microservices. And so what's next? And I really truly hope that it will not be something made from pastry. And let me explain why. Because if you remove the meat and the sauce from these dishes, you will end up just with the same spaghetti that we have. And traditional client-server applications are nothing more than just it. So ask yourself a question. What is that your applications, what are they consist of for the most part? Seriously, what other tasks does a typical web application perform other than serving requests? And so, call it as you wish, but client-server applications are consisting nothing more than the endpoints stretching from database to UI. And so, every RPC, REST, SOAP endpoints that we make are those individual spaghettis that we have there. And these request response spaghettis are just round trips that the application has to do in order when it requires some specific data. And so it doesn't matter what shape does these spaghettis take until it's just the same request response cycle. I bet this guy had a lot of fun making his application. So, okay, so let's talk about distributed systems. You might ask yourself, what are these distributed systems and why they should be interesting to you? Well, distributed systems is just a fancy way of calling a database. It is a foundation for every client-server application. So consider your SQL Server, MongoDB, Memcached, DNS, peer-to-peer torrent network. All of these are databases. And in case of databases, one tool can't fit all tasks. We can, for example, use DNS or peer-to-peer torrent networks to store banking account information. We can't use it to transfer money. And this happens because these distributed systems does not have all of the features required for these tasks. And the list of all possible features was formulated only in 1990s, and it's called a cap theorem. It was invented by Eric Brewer, and by the way, does anyone heard about cap theorem? So, okay, so there's some amount of people, thank you. Cap theorem states, I mean, this is an acronym to three terms that form the features of the database. And these are the consistency, availability, and partition tolerance. Consistency is an ability of a system to provide same view of data across whole system and for all users instantaneously. Availability means that every request received by a non-failing node results with a response. Partition tolerance is the feature of the system that allows it to function despite network partitioning. The event when your system that consists of many nodes is being split into several isolated parts. So, cap theorem states that no distributed system, database in other words, is able to implement all three CAP features at once, and leaving you with one of few combinations. So database designers are always bound by trade-offs that when designing their databases. And this is the price you have to pay. You have to choose either CA, AP, or CP kind of combinations. And the theorem doesn't state it directly, however, it leaves an impression that there is no other system possible. In other words, this theorem, it limits the designers right on the edge of CA, AP, CP features. It locks them inside dark sphere of decisions. And as a result, people who use those databases are intrinsically locked inside that sphere too. Because applications, they rely on the balance that databases provide. But in the end, this balance is not truly achievable with only two of three C or A or P features. Though applications are, when we're developing our applications, we're naturally relying on all of three features. We're doing this unconsciously, and we already know that the databases are unable to provide all of three features at once by their foundation, the database. And so the question arises, is application able to get all of three CAP features in another way? Well, similar problem is found in the architecture of skyscrapers. Skyscrapers in active seismic zones, they require additional balance. But there is nothing that they can lean on to get a hold of something. And skyscrapers, and the architecture of these buildings, they use additional balance using a special redundantly heavy sphere located at the top of the building, which looks like this. Basically, when some seismic event happens, the building just falls through for that heavy sphere and provides additional balance. It provides additional balance for the whole building. And so, returning back to CAP theorem and looking to a typical CA kind of system, what if instead of just dropping one of the features, which is for a CA system would be P, partitioning concern, what if we could get an advantage of it outside of CAP equation? Like a balance ball is being put at the top of the skyscraper, we put partitioning concern on the client side. And this is just the conjecture, but yes, it looks like the application is able to get advantage of all three CAP features at once if partitioning is being handled on the client side. Now, little explanation. CAP theorem sees that partitioning is a physical event. It is a state of distributed system that occurs due to the event of network failure. It cuts our system in several isolated parts. And if a system would continue to function in such a state, would receive write requests, it would eventually end up with having multiple versions of the same data. But on the other hand, if we allow the system to continue function despite partitioning, then similar to eventually consistent systems, we would end up having an eventually available system. Offline first system in simple words. And partition as a such eventually as a part of such eventually available system is perceived in a bit broader sense. It's a logical event, which in addition to conflicts caused by partitioning of a system, also cover the concurrent changes. When two persons are editing one piece of data instantaneously, it causes a logical event, logical partitioning. And so the same problem we get when we try to update data while being offline. And this is the same partitioning concern that we have. So by going offline, we are able to achieve an event when some data is being changed at some moment in time, but we don't know about that, and we'll change it too. And so we are getting the same kind of problem. And so let's consider it step by step. Let's talk about this new methodology, which we call reflex. Reflex is a software methodology. It is based on a simple idea that looks the following way. You just take a part of the database, you send it to the client, and you keep it fresh there. That's it. And so it's not a specific technology, it's not a specific library or framework, it's just the software development concept that consists of several supplemental concepts. And let's see what are these supplemental concepts are. The first thing we need to handle is how data is stored and used. And client is within this reflex methodology is always expected to work with local data. As soon as this person gets the data, he saves it in his local storage, in some kind of local storage, depending on the platform. So this may be like IndexedDB, WebSQL, SQLite, depending on the platform. The second thing is the fact how you exchange data within this software methodology. And the client never requests data. When client first accesses application, he gets one bulk part of the snapshot of the data that related to this user, and then he does not make requests. Server sends requests as soon as these events of changing data happen. And so there is no need to ask for data. This removes the necessity of making these spaghettis and results with having just one endpoint which is used for both saving data and receiving data. The following thing is that how we identify the user's data. So we cannot send all of the database to the client. And it is there are approaches to this kind of problem, which, for example, in Meteor are done through subscription to queries. But as we previously discussed, queries are bad. They require a huge amount of supporting code. Remember one of your tasks that you were doing recently, just showing some text on the UI? What actions does it require from developer? First of all, we need to make a query. Then we need to make a supporting code, which actually queries the query on the server side. Then we need to kind of transform the data that we received from this bare view into some probably domain objects. In other words, we're going through all of the layers that the application might have. And then we should request this data from the UI, do additional transformations probably, and then just show it. And this is just a part of the whole picture. Because when we ask for data, we can have a network problem on every of these steps. And we need to provide error handling on every part of this path. So we were only covering getting data process. But when we are saving data, we're doing just the same thing. We're writing just the same code. And so each query that we write is a copy and paste. And this is because queries, every query that we make, they are solving just one of the two tasks, either get data or save data. So how do we deal with these kind of problems when we're working on server side? We're just parameterizing stuff. We're just creating a parameter, put it outside of the procedure, we receive it through this parameter list. But we cannot do this with queries. Because imagine a query that receives like an employer, yeah, some specific from some specific table. Now we cannot ask this same query to send us the employee or something like that. Because this is different structure and it requires different query. We can do some dynamic stuff, but in general, this will be copy and pasted. And this root copy and paste cause affects all of our application. And so every endpoint that we make is a copy and paste. And what does our applications consists of mostly? These are the endpoints. So the other problem the subscription to queries have is the fact that there is no way to control the amount of data the query will send. So one way to check for how much data does queries send is to walk through every query that our application has, try it, run it with every parameter set possible, and see whether one of the parameter sets can bring us huge amount of data. And this is unreal actually. So we cannot do this. And Reflex does this in another way. And in order to get the idea, let's consider Jira or some bug tracker, for example. When you access your bug tracker, you don't see all of the data that it has. You see only stuff that you're allowed to see. And so permissions is not the only, it's not the mechanism for only providing security, but also it's a mechanism for limiting data. If we would place a link to a permission on every piece of data and then add this permission to some of the roles and then assign these roles to a user, we will be able to kind of specify which data is available for the user and which is not. This is not only safe because the user will never get the data which he is not allowed to see, but on the other hand, it is really convenient because first of all, we can, in terms of simple query, we can account for how much data does assign to some specific permission, and in regard to every user that the system has, we can count and do this counting even on the server side and see how much data each user will get and regulate these parts according to permissions by assigning new permissions, splitting them, and etc. etc. And so it seems that permissions is not just a security mechanism, but also a limitation mechanism which can be used to limit the amount of data. The following thing is the fact how we're dealing with data. So the problem with data is that the raw data, it contains surrogate links. So the links are numbers, strings, and in order to link the data using these things, we would need to perform joins by our bare hands. And this is not convenient. So in order to deal with this problem, reflex methodology will come with just small kind of library which will allow you to link your data into natively referenced data. It will connect it into full graph on the client side. So we are providing a repository pattern implementation which allows us on the client to deal with data the same way like we're dealing with Git repository. So I mean, when we're updating our source files, we're not thinking about which version does it has. So we just update them. And the same way we have a fully connected graph with all of our entities on the client side, which is connected through this library and provided for our own use. As soon as the data changes, by using some innovative technologies such as on the web part, it will be like Angular or similar two-way binding kind of frameworks, it will reflect the change automatically because Reflex will update this data upon change, and you don't have to do anything in order to provide this change to UI. You just bind your data to UI and it's automatically changed. So changing data is also very simple. You just change your objects and call commit and push, and that's it. So you're open to similar set of operations that we have when dealing with Git. And this kind of approach, it provides us the ability to stop worrying about the projected entities that we're typically making on the server side, projected entities that we're making, compound entities that we're creating on client side. And it's pretty convenient because we don't need to think in some different terms of some projected entities. We're always dealing with schema that we define. And this schema is available on the client side. So we also don't need any converting code. Yes?
Quick question to you. But you need to think about projected schema, because one permission may request for one set of tables, the other one another set of tables, and these two sets may be in some way incompatible one to another, and projected schema is much more complex question, neither projected objects.
We will come back to this question in greater detail a bit later, but the idea is that there are several phases that you are looking into when developing a project. So the idea is that initially, in first stages of project development, you wouldn't want to have full-blown schema. You would want to have like a bit relaxed schema, yeah. So in order to accomplish this, we are storing all of the data like in one table, and the data is denormalized, and so we don't have to think about these things at that point in time. But we will come back to that a bit later in a greater detail. So one of the most fundamental thing about Reflex is this P concern that we were referring to initially. So conflicts or multidimensional data is the way that we work with Reflex. And so in order to get this concept, let's refer to an understanding of conflict. What is conflict in its nature? So this is the way we're actually editing, updating data nowadays. So at point of time 10, we created some entity. Then at point of time 20, we updated it. At point of time 30, we updated previous entity. And as soon as these events happen, we lose. Now we're losing this data, yeah? So we don't have access to all of the changes that there were. But in terms of conflicts, what does it mean? So imagine a person who went offline and then started editing a version, one of the previous versions, which he didn't knew that it was changed. And this other guy, he made a change at some point in time, and then this guy became online, and now the system doesn't know. I mean, what data is more kind of, what data is right and what data is wrong. On your opinion, which of the changes is right and which is wrong? Can we, being on the level of a database, can we answer this question, I mean, in one specific way? Can we say that this version is better than this one? No, we can't.
My changes are right.
Sorry?
My changes.
My changes. Yeah. So
depends who made them.
yeah. If that's a CEO, that's one way. The changes are right then. Okay, so in Reflex, we provide a mechanism that allows us to save all of the versions on the database side. And so our data becomes an immutable. As soon as we receive any update request, we save it the way we received it. And so later we can deal with it. So this kind of approach, it allows us to come back in time and to see what the changes were at some point in time, and we can actually delegate this conflict resolution to a user. So by having this kind of, I mean, this is just the imaginary case, which shows kind of more an edge case, but in reality you would have a pretty few amount of conflicts. So this case shows that it shows a lot, and we will be discussing it a bit further. But by using this system, we have no need for doing logs, a mess our database with some garbage data, which in fact we need to kind of decipher when we're working with logs. In this case, we see what happened at what moment in time. We can analyze it, we can come back to it, we can review it, we can affect it in any case. If we are allowing a user to change any of the versions on any step in time, this allows us the ability to merge data, so that when the user gets two versions of the same data, he sees that these are the two versions. And in place of our probably Jira, we can just, instead of showing one form with questions or something like that, we can show a tab control showing two versions. And this is the convenient part, because having this system will allow a user to see the changes that you have made and my changes, and pick parts which are correct from your side, from my side, join them, and have one record, and resolve this conflict by deleting one of the versions. And deletes are also immutable. They don't affect data. They are also inserts into the system. Okay, so how to deal with this kind of data? It seems like a complex concept, but it's not. If we add a timestamp to every record of our system, we would end up, in order to get the updates, it will be a pretty simple kind of query. Suppose we have a timestamp, and the user that went offline, he had data at some point in time. Let's say he had data at time 20. Then he comes back online at time 30, and he tells the server, "Hey server, I have data which is up to date until moment of time 20." And server knows that now is moment of time 40. So he sees this thing, and what he needs to do, he just needs to go through his table and pick the records which has timestamp above 20. And this is the most simple query that is able, that we are able to provide for a database. There is no simpler query for a database to execute. Oh. So in reality, the concept is a bit more complex because we need to we would want not to send all of the intermediate updates to the client. If the client has gone offline like a year ago, he has pretty huge amount of changes. We wouldn't want to show the intermediate changes for this client, right? And so in order to account this feature, we only need a timestamp. But the query gets a little more complicated, but it has the same simple nature as I described. So the query is simple, and it allows us to cut off all of the intermediate changes and not send and overwhelm the client with intermediate data. And so this is how this reflex methodology, what it consists of. We are planning, we have some plans to provide full documentation, everything, and in order to keep in touch, just maybe save our links, Twitter, Facebook. Don't look at the GitHub at this point in time. So we will be making an announcement soon enough, and so this is the idea that we have about Reflex. If you have some questions, let's probably discuss them. Yeah.
Excuse me if I'm wrong, but in my opinion, you invented JIT.
No.
Why? What's the difference? Where's the catch?
JIT is only a part. JIT is only a part of the client side. So,
They give you the same option of conflict resolution. Clients does it, not server.
The idea is that working with offline may seem like a simple concept, but in reality, it's like walking or dancing a tango over the minefield. There are huge amount of edge cases that you need to account. When you have this query which serves you data, it has to account time in very specific and very accurate manner. And so there are a lot of concepts. So it may look that on the client side, when you're working with your data, it looks like, oh, okay, we have a Git. But in general, it's a bit more under the hood. So the idea is that there is a special way how you deal with data. The way you save it to the database. There is a special way you're able to analyze the data. And so I'm not sure. Maybe we can call it like inventing a Git for the as an architecture of client-server applications. But there are some differences, I would say.
Okay. Good question. In the database, you store data as append only like events, I don't know, the changes log, whatever you can call it. But on the client, on the UI, we need the final state of data. Who's gonna aggregate that stuff on the client? So on the client, we're getting all the log, and then on the client, we aggregate that and get the final version. Or
no, the server does that actually. So we have special queries that are able to kind of calculate the diff between the data that you had at the at that moment in time and the data that you need to kind of have right now. So it calculates a difference which is sent in terms of instruction. It says that remove this version, add this version. It works like that. And this instruction doesn't contain all of the intermediate changes. It just says which versions. And the idea is that making this kind of query, it took me around 4 months to create the query itself. There are a lot of different kind of, I would say, physical constraints, because it requires us to deal with time, and time is different on different machines. And in order to deal with these problems, we need to account not only for the time, but we need to make this query as fast as possible. And there are, when you try to combine all of these ideas into one kind of query, you get a really tough problem to solve, technological problem. And I will, it is solved already. I have a test application, but we will be making an announcement and showing a full-blown examples and providing you with boilerplate which allow you to play with this kind of technology in some recent time, in some recent future, but we're not showing it at this moment in time. Yes?
Could you please open the slide with the big skyscraper?
Sure.
Thanks. So yeah, here is a trick. From the whole platform perspective, this is the way you move out partitioning out of the system across multiple users. Okay, but the reality is that 2010s, all these years, the CAP theorem actually results only 2 options out of 3. There is no CA. You, because of the volumes of the data, partition tolerance is what you 100% need. And you play between consistency and availability using eventual consistent system. So my point is that this is kind of a trick, that there is no CA as a result. There is CP and AP.
One thing that I haven't pointed out is that we're using on this for this example application, we're using SQL-based application, which provides CA by default, right? So the idea is that when your database cluster gets partitioned, the nodes are not able to function in this kind of scenario. And this is perfect availability, right? So when the system doesn't function, we have no availability. As soon as the system restores, we have the ability to provide a response for every request. This is the availability, right? So the idea is that partitioning problem in a typical application would be just dropped. Our system is unavailable, sorry. We can proceed with this kind of problem when our system is being partitioned and have the partitioning kind of handled in other part of the system, on the client side. And our system can still receive requests, and it will be okay for the state of the system to be in partition state, to save multiple versions of data. The system will be ready for that. It's not a problem at all.
Yeah, I got it, thanks.
And that's how, I mean, it's just a conjecture. I'm not saying that we've broken the CAP theorem. I'm saying that it looks a bit weird because it seems like we're having 3 of these features at the same time. And by the way, saving data with Reflex is always bound to transaction. So I see that we're almost running out of time. So maybe a few last questions or one or yeah.
Can you please compare it to, for example, Firebase?
Firebase. The Firebase, yes. I had an opportunity to work with Firebase. Firebase takes no responsibility about conflicts resolution. You're on your own with that. So it overwrites data as soon as you update it. And if you have conflicts, yeah, it's interactive kind of, not like it's interactive database which sends you events as soon as you kind of make them. But it doesn't deal in any way with conflict resolution. It doesn't read data. The main idea behind Reflex is that this multidimensional data. It changes our perception of data. We had data for the past few decades as a single term. Consider like simple maths, the quadratic equation, right? In order to solve it using any parameter set, we should go to complex plane. We should use complex numbers. And this is the notion of kind of multidimensional kind of data, right? So in order to solve some problems that we are stumbling on in our development life, we have to go outside our typical kind of perception of things. And treating with this multidimensional data, at this point, it has some kind of problems, right? There are some things. When you want to sort your data, and when you have several versions of the same data, how would you sort them? So there are some issues. These are solvable, by the way. But in any case, it raises new, of course, questions, new issues, how we deal with this, with that. But it's a new concept. It's kind of a whole new world beyond this dark sphere that I've mentioned.
Look at versions. It's the same like two different. It's the same like a conflict.
Right.
You have two versions. But,
Yeah. You have one version, you have no conflicts, and there's a one possible way when you have no versions at all, but you have a reference. What you do at this point in time. So there are new things. So stay focused. Use our Twitter, use our Facebook, and we will be making announcements, and very soon you will be able to play with this. Thank you.